Alright, so today we're going to look at what happens when you don't have odd powers of cosine or sine. In the previous video, we looked at the case when you had an odd power, so you could separate one of those sines or cosines and didn't use it for your du. But in this case, we can't. I mean, let me just, this is not going to work, but we're going to erase it anyways after a second. But now you have a problem because you want to be your du. U would have to be sine of x, and then du would be cosine of x dx. But there's no sign there, and there's no trick I can play because the best thing I could do is I'd have to choose whether plus or minus 1 minus sine squared of x, and then my integral becomes 1 minus u squared and square root of that plus minus. That just becomes a disaster. So that's not going to be useful at all. So that approach, just scratch it. But there is one formula that you may or may not remember, let's say. And that formula is the half angle formula. And you can rewrite it in this fashion. So cosine square of x is going to be 1 plus cosine of 2x all over 2. And the sine squared is going to be the same thing, but with a minus. So if I use that formula here, I can plug it as 1/2 the integral of 1 plus cosine of 2x dx. Now, the only thing I advise is that you be careful here, because some people just say, well, that's 1/2 of x, which is correct. But then they say, well, that's just, you have cosine, then the antiderivative is sine, and just write 1/2 of sine. But you gotta be a little bit careful. So I'm not gonna do the plus c just yet, because I'm gonna isolate that integral right there. So notice that there's a 2x there, so you gotta make a u substitution, and this is usually where I do my u sub, so I'm gonna have to do it here. U is 2x, which gives you that 2 dx is du. Well, I'll reverse the order there a little bit. But what that tells you is that when you're going to substitute in that dx, is going to be 1/2 of the du. So whenever you do that, you're going to have 1/2 of x, and then minus negative, so it's going to be, what did I say minus negative for? I don't know. I meant a 1/2 times 1/2, because this is going to become 1/2. So plus 1/2 times 1/2 minus negative. Where did that come from? I don't know. And that's going to be 1/4 integral of cosine of u du. So you see, let's go to the highlighter. My du, I'm going to write it first. I'm going to write the 1/2. That was supposed to be a 1/2. Let's write it in line because I cannot fit it. So 1/2 of du is dx. And then if you notice, this right here is what I'm plugging in for the 1/2 of, oh my gosh, fail again. The 1/2 times the 1/2, so the 1/2 is involved in here, and the du, that's going to be my dx. And then the cosine of 2x becomes the cosine of 2u. That was a bit accidented, wasn't it? Yeah, a little bit. Alright, not enough to re-record it, I hope. If you have questions, please do let me know, either by email or in the comments, whatever you prefer. But do let me know if this is confusing. I hope not. So I just integrate my cosine now, and I get sine of u. And now I take back my substitution, because you know that no one cares about u, they care about the x's. Is that right? Something like that. Terrible. And that gives you your integral right there. So you use the half angle formula for that one. So let's do a couple more, and let's see how we do. Okay, so now we're going to throw a sine squared to it. So what do we do? Well, still the same thing. You just replace this one with 1/2. I put out here. I would have to put out here. So 1/2 of 1 plus cosine of 2x. And then I would have to substitute this one with 1/2 of 1 minus cosine of 2x. So the 1/2 times 1/2 I'm going to write as 1/4 out here. So I just use the formula that I had before. I used them twice, okay? Now this is a difference of squares. So it's not too bad because I get 1/4 of the square of the first is 1 minus the square of the second, which is cosine squared of 2x dx. Okay, so the first term is really easy to address. It's going to be 1/4 of x. No troubles there. And then minus 1/4 of the integral of the cosine squared of 2x dx. Now here I can do my u substitution, so I'm going to open up a box here. U is going to be equal to 2x to take care of this, just like we did before. But you'll see we'll end up with a cosine square of u, which is the integral we computed before. So I'll go back and look at my notes, and I want to write the answer for that one. But at the moment, I want to have that. So I'm going to have a 1/2 of du is dx. And that's what I'm going to plug in for my dx right there. So this dx, we substitute it with that. And then I'm going to have a cosine of 2x is going to be cosine of u, cosine square of u rather. All right, so I'm going to do that substitution there. I'm going to have my 1/4 of x minus 1/4 of the integral of the cosine squared. I forgot something. Cosine square of u, the dx I said was 1/2, so 1/4 becomes 1/8 du. Now I gotta go back and look at what the integral of the cosine square of x dx was, and I want to write down the solution. And that is going to be minus 1/8. Now this is a 2u, so it's going to be 1/8 of u. And this is going to be minus 1/32 of the sine of 2u, but I can, by the way, I already took back my substitution here, so x, and then instead of sine of 2u, it's going to be sine of 4x plus c. And now we simplify that, so 1/4 minus 1/8, this is 2/8 minus 1/8 is 1/8 of x, and then minus 1/32 of sine of 4x plus c. And that's the answer we get. All right, so let me do one more. All right, so the last one, again, we're gonna go ahead and use our formulas. This is gonna get a bit messy, but this is what it is. So we're gonna go ahead and write it out. I was gonna start moving constants in and out, but I don't think I'm gonna do that because I'm gonna have 1/2 to the power of 6, 1/2 to the power of 2. There's gonna be a 1/2 to the power of 8, which is 1/32. I could put it out there. Now that I said it, it's kind of better to do it that way, but we're gonna do it in steps. So 1 minus cosine of 2x to the power squared to the power of 6, which is annoying. And then this one is going to be 1 plus oh my goodness, this is to the power of 3. Well, still pretty annoying, but a little bit better. Why is it to the power of 3? Because I skipped one step. Let me show you the step I skipped, because you only have a formula for sine square of x. So you have to write a sine square of x and then write it cubed and then cosine square of x, because you do have a formula for the cosine square. So that's going to be cubed, my bad. And then plus cosine of 2x. That one does not have any power anymore because it's just the formula for the cosine square. All right, so that's where your exponent should be. Now I'm going to pull the constants out. So the 2 is going to be cubed here, times 2 again is 2 to the power of 4, which is 1/16. You see I had done it incorrectly because I had done power of 6, it was power of 3. Anyways, good thing I decided to write it, otherwise we would have not liked that. So 1 minus cosine of 2x to the power of 3 times 1 plus cosine to the power of 2x dx. So that's a bit of a mess. I'm going to try to simplify things a little bit. We're going to have to FOIL quite a bit, but in the interest of simplifying, I want to peel out one of these guys, because when you multiply one of these guys with this, it's a difference of squares. So I'm just gonna write 1 minus cosine of 2x. I'm gonna square that one. I want to peel off one of them, the one that is remaining, and then 1 minus cosine of 2x times 1 plus cosine of 2x is a difference of squares. So I want to have 1 minus cosine squared of 2x. Alright, so now I just have to FOIL out a square, which is not nearly as bad, and then I'm going to distribute these terms, grab a bunch of cosines, and that's how we're going to go about it. Alright, it's a long problem. I mean, we have combined power of 6 plus 2, 8. So it's going to take a minute no matter how much we don't want to do it. So whenever we square, this one is going to be 1 minus the double product, so 2 cosine of 2x plus the square of this one, which is cosine of 2x squared, and then 1 minus cosine square of 2x. So we still have to distribute again. So when I go ahead and do that, and that's going to be demotivating. No, I mean, it's going to be, I'm going to FOIL it out. So first you get the 1 times, it's going to be, you know what? I'm going to go ahead and be a little bit faster about this. This is going to be a polynomial on cosine. So I'm going to have cosine cube of 2x is going to appear only one time. And that is when the cosine square hits that cosine. So I'm going to write that one right away. Also, the cosine, the linear term is going to appear one time. So I'm going to do minus 2 cosine of 2x. So that one we had to FOIL anyways. But there are going to be some terms that are going to appear in two different ways. For example, the cosine squared, which is the next one, will appear one time when I get the 1 times cosine squared, and then minus 1 when I multiply this cosine square again. You see, I get a cosine square from this multiplication, and I get another cosine square from this one. One is going to be a plus 1 coefficient, and the other one will have a minus 1. So when I add them, when I fold them out, they will cancel. So those I don't have to worry about. So I'm going to move to the cube. So how can I obtain a cube? Well, a cube you can obtain when you multiply this times this, a cosine cube. You see, I'm just looking at what exponents I get, because the largest exponent is going to be when this hits this one, which is a degree of 4. So I'm going to go, I start with the 0 degrees, then the 1, the 2 cancel, the 3 is going to happen when I hit this one with this one, which is going to be a negative 2 times a negative is going to be plus 2. So just trying to keep track of the coefficients. So plus 2 cosine cubed of 2x. Now cosine cubed I can address in the way we did the odd powers, cosine square as well. The 1 is just integrating, but the last one is going to be a minus cosine to the 4th of 2x, all of it dx. All right, let me check that I did everything correctly. I'll come right back in a... Yes, so far so good. So always verify as you go, because you don't want to get to the bottom of the problem and then find that you made a mistake and then have to go all the way back. That would be definitely painful. All right, I'm gonna skip a few steps in my integrals, because I feel like we're comfortable computing the integral of 1. It's going to be an x. The integral of the 2 cosine of 2x, you're going to make a u substitution. U equals 2x. The du is going to be 2dx, which you already have. So this is just going to be a sine of 2x. So that one we don't have to do too much work. Now this cosine cube, remember, is one of those we're going to have to write as, well, we're going to integrate that one. I forget about it. So now the 2 and the 1/16 is going to be a 1/8. And then the integral of, and remember that to do these kinds of integrals, I'm going to go ahead and separate it out. Why? Because I have an odd power, so I can peel one off. I'm going to turn this one into sines, or 1 minus sine squared, and then I'm going to do my u substitution, u equals sine of 2x. All right, so that is going to be one of them. And then I have the integral of a minus 1/16, an integral of a degree 4th. So cosine to the fourth of 2x dx. I know it's a little bit unwieldy, but it's okay. All right, so this one right here, my u substitution should be u equals cosine of 2x. Du is going to be negative sine. Oh my goodness, I haven't done the whole change. That's what you should not do. What we need to do, one more step before we get to it, is change this one for 1 minus sine squared. All right, so I feel like I'm gonna copy paste it so I can then just modify it. All right, so copy, I'm gonna paste it here, paste. And what I want to change is this cosine squared. I'm gonna have to write a little bit small, but it's okay. That cosine squared is gonna become 1 minus sine squared of 2x. You see I changed that one right there. And this one, I'm gonna write it as cosine squared squared. So let's change this one for a square. And let's put a square out, because I know what I'm gonna do with the cosine squared. I'm gonna change it up into a 1 plus, or 1/2 of 1 plus cosine of 2 times 2x. You see, I have already a 2x. I have to multiply times 2 again to use my formula, so it's going to be a 4x. What I'm saying is, think about this one as a cosine square of u. That's going to become 1 plus cosine of 2u over 2. But now u is going to be, in our case, 2x. So this is going to be 2x here instead of u, and it becomes 4x, okay? That one is one that sometimes people don't like, so I'm going to rewrite it. So with that, I'm going to copy this one. I know, a lot of writing. Paste it there. And we're going to go ahead and now change this one. With 1/2, it's going to be squared, it's going to be 1/4. Is that right? Okay, if I just put a 64 here, which is 4 times 16. So the 1/2 that I wrote a second ago. And this would be 1 plus cosine of 4x. Because the 2, remember the 2u becomes 2 times 2x, which is 4x. Alright, so now we're in position to start computing our integrals, the leftover ones. So again, I'm going to do my u substitution for the first integral here, u equals sine of 2x. Du is going to be derivative of the sine is cosine. Leave a little bit of room for your 2 because of chain rule. So cosine of 2x, leaving the inside unchanged, times the derivative of the inside, which is the derivative of 2x. That's a 2 dx. And so I am going to put a 1/2 here. So 1/2 du will be the cosine of 2x dx. Just as in the previous video. And so if you haven't watched that video, you have to watch that one first. Otherwise, this is not going to make any sense. So that sine squared is going to become 1/2. When you do your substitution, oh my goodness, I chose the wrong thing. The cosine of 2x rather becomes your 1/2 of du. All right, so this is gonna become very interesting because I don't know where I'm gonna fit everything. I have to use multiple lines, I suppose. All right, so I'm gonna write again. So 1/16 of x minus sine of 2x, and then you're gonna have 1/8 of the integral of 1 minus the sine of 2x is going to be u squared, and your du is going to be a 1/2 of du. Let me put the du here and multiply times 1/2 out here with 1/16. All right, and then the next one is going to become, I will have to do a, say, v substitution because I ran out of u's. And I'm going to change that one to a, well, firstly, I'm going to just integrate this. Oh, I have to FOIL still because I have a square. Okay, I'm going to address that one in the next line. I'm not going to do all that right now. We're going to address little by little. Yeah, it's going to make the video a bit longer, but I think it's going to be actually better. Let's move it over here. Let's keep it there. A little out of the screen. You can zoom out a tiny bit and keep writing. All right, so this one right here, then that becomes 1/16 of x minus sine of 2x, and then plus 1/16 of u minus u third over 3, where u, remember, I'm just integrating, is sine of 2x. So I'm going to be able to combine some of these guys here. I think they're going to cancel a few of them, so minus 1/64th. And I am going to FOIL this one out. So it's going to be 1 plus 2, cosine of 4x, and then plus the cosine squared. Ooh, running out of space. Let's scroll a little. Oh, that's where the page ends. Okay, well, I guess I'm gonna have to go down to the next line. So, plus, as I said, cosine square of 4x, holding the x. Well, this problem has been interesting, to say the least. Alright, so now taking back substitutions, this u is going to become the sine of 2x. So I can distribute and eliminate things, so that sine of 2x will cancel actually. So I get 1/16 of x, and I'm going to have this one minus 1/16. Oh, the x is up here, not down there. And then minus 1/16. 16 times 3 is going to be 48. So 1/48 of the sine cubed of 2x. That's just taking my substitution back. As I said, the sine of 2x here and the sine of 2x here cancel, because one is minus, the other is plus. They have the same coefficient. They cancel, and then I'm going to have minus a 1/64th of x. Just integrating this one. I'm going to integrate this one directly, just because it's a u substitution. U equals 4x. So I'm gonna go ahead and save us a little bit of time. So we're gonna have a 2 that comes out, so it's gonna be a 1/28th, a 1/128th of the sine of 4x. And now this one, I unfortunately have to write the integral again. So the integral is gonna become minus the integral of the cosine squared. It's gonna be 1/28th, 1/128th of the integral of the cosine squared. The 1/2 came from the cosine square, substituting it in, so it's going to be 1 plus cosine of 8x dx. Is it the end? Not yet. We have to integrate this, but that we are almost ready to do. So continuing, again, this is a u substitution, so going to give me an 8th denominator. But let's see. So I'm going to have a 1/16 minus 1/64. This is going to be 4/16. 4/64, sorry. So 4 minus 1 is going to be 3/64. Now 3/64 minus 1/28. 3/64 is 6, so it's going to be 5/128. So combining all of the x's. All right, and now this one stays alone. So 1/48 of the sine cubed of 2x minus 1/128. That one stays the same, of the sine of 4x, and lastly minus, and I'm gonna have here the 1/28 divided by 8 when I do my u substitution. So it's going to be my power. So is that 1024? I believe that's the power, next power that would correspond. So 1024 of the sine of 8x. Alright, so after this behemoth, I had to go back and check on the computer algebra system to make sure that we got it right, and yes, we did. Do not expect one of these in the exam. That one was quite a fun problem. Um, yeah, I don't even think I'm gonna give you one like this for the homework. Nonetheless, there it is. You have seen it one time at least.